And we're live.
Hello everyone, welcome back to another session of AMA, the last one for the year. And today we have with us Tableau and Rikin, and we're going to talk to you a bit more about data visualization. So first up, we're going to answer some of your questions that you had in the poll. So let's take it away.
Okay, so
can you see the screen?
Right, yeah. Everybody can see the screen. Good. Okay, so let's start with question 1. Okay, so how important is data visualization to a data scientist? The way I put it is, unless you want your audience to sleep, you should always try to make impressive and impactful data visualization, because it's the best way to convey your message and findings across. And it'd be a waste if you spend days trying to build the models, the kind of predictions, and end up you fail to convince your stakeholders to buy into the models because they're not impressed by your presentations. What do you think?
I think that's true. It's very important. Like a lot of times when you deal with data, you think of it on a very numbers level, but you have to understand that the people are presenting to don't think of it that way. So it's good to give them some sort of intuition where they can grasp, oh, that's what I'm talking about, and then that will save you a lot of trouble of explaining exactly what you're doing sometimes.
Okay. I actually have a question. So, because data visualization takes up additional time, it's more work than the basic manipulation. So, how do you find a balance between making your data look very pretty and presentable and focusing on the data, the information that you're trying to deliver yourself?
Well, I think for me personally, I do things kind of concurrently, because I also make use of visualizations to help myself look at understand the data better. So these might be things that eventually I will show other people. But then of course, when you're going to do a presentation, you will of course want to beautify things, and then try to think of ways to express yourself better. So I think it kind of goes hand in hand, because it's not just purely for presentation; it helps yourself too.
Okay.
Yeah, I think the way I put it across is, imagine you're going out for an event, right? You should dress to the event. Let's say you're going to the wedding dinner, you should dress up, wear blazer, and everything. But if you're going to the beach, right, you don't dress up as much. So same goes for data visualizations. How much dressing up you should do depends on the events you are going to. If you're presenting to just a manager, right? I mean, the basics will do, I suppose. But you're presenting to your clients or your board of directors, then of course you need more dressing up, like put on a blazer, put on a tie, change the colors, put on mistakes, everything.
Okay, cool. Shall we move on?
Okay, next question.
Okay, apart from Bokeh, what are other visualization libraries or platforms being used in your data science roles? On the other hand, what about commercial apps like Tableau?
Yeah, so for the first part of the questions, you can use Seaborn and Matplotlib. So these are the usual three usual suspects that you usually use in your data science data visualizations. But of course, you can explore other tools as well, like Chartify. So Chartify is a new library developed by Spotify team. So they are saying that it's based on Matplotlib. So you can think of it as Matplotlib as the very low-level code, meaning that you need to write a lot of lines of codes to get a graph. What Chartify did was they simplified everything. So I think the base model is still based on Matplotlib, but the number of lines of code they need to write to do up a chart is a lot lesser. So you can just Google Chartify by Spotify, and you should be able to install the packages in your library to use it.
Cool.
I got another one that's very useful if you happen to be dealing with a lot of geospatial data is Cartopy. So yeah, so like cartography, but with pi at the end.
Okay.
So Cartopy. It's also built on Matplotlib, and then you have a lot of things built in to help you visualize spatial data. So you can set, the kind of grid systems you want. You can auto generate sea and land, and then terrain height. You can generate rivers and country boundaries, all that sort of things. So it's very useful when you're dealing with geospatial data.
Yeah, I think at this point of time, I also have to add that as if you're interested in data science, it's very important to develop that curiosity. and the skills to learn independently. Because a lot of time, if I use things like Shopify or other libraries developed by other companies, right? You won't see a training course on these companies. Like for example, if you use Bokeh, you can see DataCamp, there's one whole lesson on this. But if you start using Shopify, you won't expect Spotify to develop a course on this, right? It's not their business. So we have to go in the website, look at how the code is being written, and the examples is being given by the Shopify team, and the various use cases and the documentation. So at this point of time, we are at week 7 of the data science course for AI4I. So I hope that by this, at this point of time, all of you here, the very few who are not away from holiday yet, we have really developed the skill set and mindset to be curious and to seek answer on your own without other people guiding you. This is very important because at a professional level, you won't expect to look at a course and to solve problem at each step. You have to reach that point where you are comfortable in going to the website, read the documentation, understand how the code is being written, test it out on a notebook, and see whether it works or not. So it's only at this level you can say that you're ready to become a junior data scientist, because it's only at this level you are independent. You don't need to depend on people to handhold you. You can start to troubleshoot your own problems. So I hope at this point of time, you will have this mindset, skill set in you. Otherwise, it's very hard for you to move away from data camp to whichever areas intending to go. Yeah. Okay. Next.
Okay, so 100 features, sns.pairplot looks too small to be feasible. How do you start guessing which 2 columns to start to make bivariate?
I think this PCA comes in handy. What do you think?
Absolutely. So, I mean, it's a combination of things. So maybe if you have domain knowledge, then you will know, what makes sense to be plot. But if not, you will have no choice but to either reduce the number of dimensions, or you can use some sort of feature selection model to choose the most important features, and then you can plot those as well.
Yeah, so I think one of the lessons in data camp talks about PCA. So PCA stands for Principal Component Analysis. So basically what it helps to tell you is that which of the variables in our data sets or the features in the data set varies the most. For example, if we have 100 features, right? Let's say out of the 100 features, right, 80 of the features, right, they're all fixed value, like all males, then all white, right? So if it's all fixed, right, there's no variance in the columns, right? Then the data itself is really not that important. Maybe then if you want to look at the income, right, for example, then the income fluctuates a lot. Then the education differs. For example, some guys are bachelors, some guys are PhDs, things like that, right? So by identifying the columns which varies the most and put it into the model, then it can tell you which are the important features that you should be looking at. Right?
Sure.
Yeah.
Okay, let's. In a bivariate plot, I see suggestions of using size or color of markers to represent a third property, to guess at the third property being a confounder of the first 2 properties on the XY axis. Is this a formal method?
I wouldn't say this is a formal method or not. Actually, this is adding another dimension in the data. So imagine that you are trying to present something that is very complex, right? You try to embed a lot of information into the graph, right? Try to embed as much information as possible. So other than X and Y axis, right, which is the values, other things you can do is the size of the bubble. If it's a scatter plot, right? For example, if it's a big value, then the bubble could become bigger. Then in addition to that, if the bubble represents something, let's say a developed country versus a developing country, then the color coding could be like red for developing and blue for developed. Then the size of the bubble could be the population size or the income level. Then maybe the x-axis is the year, the y-axis is the per capita income, or things like that. So this is a way for you to embed more information into the graph to make it stand out. But of course, it doesn't mean that the more information I embed, the better it is. You have to embed relevant information. For example, based on the things that I mentioned earlier, it could be a graph on how poverty or countries that are in developing or advanced stage have different life expectancies. Right? So this is where having such elements to the graph will help. If it's a very simple graph, you just want to understand the frequency count, then you don't need to have this fanciful graph.
I think as a good rule of thumb, you could have up to maybe 3 features in the graph, and it will still be quite intuitive. When you get to more and more features, you're going to have to spend more time yourself explaining what each part of the graph means. So as beautiful as the graph might look, maybe you have to consider that people will still be confused. So in general, just follow the principle of keeping it simple and straightforward if possible.
Cool. Right. What is the purpose of visualizing PCA or t-SNE output? I always see plot summary endings with the clusters are well separated, and this seems to just be repeating what is already known. Is it to check if the number of clusters selected is correct? Shouldn't that be controlled quantitatively?
Yeah. So for this question, right, I think it ties back to the first question, like the importance of data visualization. So the purpose of visualizing PCA is to identify which features are the most important, and the purpose of t-SNE is to visualize the clusters that the unsupervised learning method has generated. Right. So these are 2 different methods of visualization, and each have a different purpose. And the last part of the question is to check if the number of clusters selected is correct. For this, it's hard to say because if we are coming from the background of doing unsupervised learning, then usually when those unsupervised learning, right, you might need to set the number of clusters that you think you want to have. Right? For example, k-means clustering, right? So the way to measure it is that, for example, you can look at serial score to see whether the strength of a cluster itself, like for data points within the same cluster, how close are they together? And for data points across clusters, how far away they are from each other. Right? So definitely there are some measures you can use to quantify the strength of a clusters. But at the end of the day, I think domain knowledge comes in to see whether it makes sense or not. For example, if you're doing an unsupervised learning on gender, so suddenly the model gives you 3 genders or 4 or 5 genders, right? Then you might need to question whether there's something wrong with data sets, or there's something that need to tweak because it's only male or female, right? Biologically. Right?
Yes.
Yeah. Also, like, I think it's really more art, the visualization part. I mean, you can use any amount of metrics that you want, and they will usually work for some ideal case where there's 2 beautiful clusters, 1A, 1B, and then you can see that it's very nicely separated. But sometimes in your features, the way you cluster things might not be intuitive. Things might not be like in blobs. They could be like in a curved shape or an S shape. So this is when having the visualization will allow you to know whether the clustering works or not. Because when when you have this kind of strange shapes, you can get very good scores, but yet have what other humans would consider bad clustering. So you kind of need both. You need a balance with numerical, quantitative clusters, and then looking at it and feeling that that makes sense.
Okay. Given a huge amount of data, how do you know which subsample to zoom into, or the columns to group by on, or the tables to join together before plotting? Is do as many as you can the right way, or are there certain guiding rules of thumb?
Okay, what do you think about this question?
Well, this is exactly what exploratory data analysis is for, because you enter it and then you give you more intuition about what each feature tells you. So, for example, usually when we start, if I'm given a huge data set, and I'm in a hurry, I'll say, okay, maybe I'll just take the first 1,000 rows, and then I'll start doing analysis on that. But then if you find that, oh, the results seem a little bit strange or like very skewed, then it could be a case where the data itself is ordered in some way. Maybe the first, they collect from one location first, and then they collect data from the second location. So I'm only taking data from one place. Then if this is a situation, then the rule of thumb is that you shuffle your data, and then you take up samples, and then you then you try and analyze your data again. So if in doubt, just randomize. Yeah. So I mean, ideally, when you go into this, you should have some sort of idea what each of the features mean. So you want to apply a domain knowledge and then take out the features that are important. But in a case where you're just given 10,000 columns and none of them have any titles and zero explanation, this is also when tools like L1 regression, principal component analysis, or t-SNE can help to reduce the amount of dimensions, and then you can work with those using your normal data skill set.
Okay, let's go to the next question.
Okay, so now EDA plus visualization.
Okay, so we commonly see plotting for EDA before modeling. Is it useful after modeling to verify how good the model is?
So again, when do you usually plot graph? Do you plot it before EDA, after EDA, during EDA, or after everything is done?
I normally plot it during the EDA process to get an idea of how different variables relate to each other. To answer the point about plotting after modeling, this would be maybe if you're doing like some sort of clustering, then you would do some plots after that to see whether clustering makes sense. You also do plots to verify things like confusion matrix. So if you're trying to predict classification, you can plot a model to see what kind of whether your model is misclassifying something consistently or is it getting everything correct. So these will be examples of when you would do plotting after model. But in general, the plots you do before and after modeling, they differ a little bit.
Yeah, I think it's important to know what you want to achieve before you do anything. Right? It's not like what's the rule of thumb or what's the right approach. It really depends on what you want to achieve. Right? If your boss comes to you and say, hey, I have this data set, let me know what it's trying to say. Yeah, of course, you need to do some graph to actually understand what the data is about. But let's say your boss comes to you and say, hey, I need to predict a sales figure. Then you know that, okay, sales figure, what you need to know. You need number of accounts, number of sales receivable, the number of like, I don't know, COGS, things like that. Then you need to start getting these relevant features in to actually do the modeling. So at the end of the day, it really depends on individual situations and the problem that you're trying to solve.
Okay, cool. Let's see. Should EDA be done on training set only or with the test set too? If only done on the training set, I wouldn't know the Titanic holdout set does not contain cabin type T from one hot encoding cabin type on training set, making it impossible as a predictor in the model. If you include the test set, then there will be data leakage.
Yeah. So I think for the first part of the questions, EDA should not be done on test set, because if you do an EDA on your test set, technically when you do the modeling, subconsciously, you will start to tweak some part of the model so that you give better predictions when you test it out on a test set. Right? So there is a rationale on why you will take out the test set and put it aside. This is to prevent something called information leakage, right? If I know the future, my past will be fantastic. So if I know the future, my present will be fantastic because I can do modeling to try to make my present closer to the future. Yeah. So ideally, you should not even touch the test set at all. Yeah. So on the second part of the question, that's interesting. So Liken, what do you think? Like, if I don't know what's the test set, and then do a lot of like tweaking, EDA, modeling on my training set, what if the test set doesn't have the information?
So in this case, you would want to try and build something slightly more robust. So to answer this specific question, you will know that there's a type T, in your categories. So if I'm trying to build something robust, I would maybe have type A, type B, type C, and then type unknown. So that way, anything that doesn't fall into the 3 categories that you train on will drop into the unknown, and then hopefully your model learns to disregard the data, for example. Because even if you did include type T in your training set, you have only 1 data point to work on, right? And that data point is on your test set. So if you include this type T variable into your training set, you are actually leaking the data from your test set in. Because when you do your prediction, there's only 1 type T, and then with that 1 type T, there's only 1 value, and then your model is just going to guess that value, and then you get 100% accuracy. But that's not the case.
Yeah, and one more thing as well, right? When you separate out a data set to have a test set, it should randomize it. It shouldn't be a case where your training set has all type A, your test set has all type B. Then it's a very, very bad data set. So if you go to Kaggle, right, usually the data sets they prepare for you is really randomized in such a way that it should be representative of the entire populations or representative of the data set that they are giving to you. So it's very important that when you prepare your data, you should always shuffle it first and make sure that you get the right representation of each of the classes you have before you start doing modeling. And in case you're wondering how to do this, right? So Scikit-learn has this very easy module called train test split. So basically, in a train test split, in one of the hyperparameters, right, stratify, you should put equal to y or the label. So when the train test split shuffle your data, you ensure that whatever labels that you have in your data set, the train set and the test set will have approximately amount of same classes you have and the samples as well, so that when you do your modeling and test it, right, you'll be representative of the actual world.
Cool. How do you decide if something is an outlier or that the environmental conditions have shifted? Is the outlier a concept that is specifically defined for the problem, just like the loss function or the performance measure?
I think this question is interesting. So how do we define an outlier? So Likian, how do you define outlier?
Wow, that's a tough thing to define. I think for me, an outlier, there will be 2 kinds. There is an outlier that is from the consideration that your data collection process has gone wrong somehow, or something weird has happened. So that would be an outlier where there's some sort of error. And then you have an outlier where the data collection process is correct, but then it just so happened to be an extreme value. So like if I'm doing sales figures, maybe all my products, everything sells within this price to this price, but then suddenly someone places a huge order and then it's like way outside. So that will be an outlier. So how you decide to deal with it really depends on your overall goals. So if you are trying to just predict within this small range and you're okay that for this kind of like huge orders or huge amounts, you don't need to bother about it, then you can just throw it away. If not, I would suggest using certain methods like power scaling, for example, or log scaling to try and bring your numbers to a closer range so that you can include outliers. So do you have any other methods?
Yes, I have 2 methods. So the first method is domain knowledge. For example, if we are trying to do outliers analysis of demographic, right? So if you see someone with a height of 4 meters, then of course it's an outlier, right? So this is where domain knowledge comes in, right? Depending on the context, it could be something that could be outlier, or it could. Yeah, so this is the first approach, the domain knowledge approach. The second approach is statistical approach. You can say that, for example, anything more than 3 standard deviations in the dataset is considered outlier. So that means you're saying that the extreme right and extreme left values are outliers, then you move them. Of course, then if you do this approach, you have to understand the context as well. So let's go back to the example of height and weight. Let's say, for example, if you do the 3 standard deviation approach, right? That means Anyone with a normal weight of 40 kg, for example, will be dropped out of the dataset if they are fall within 5% of the extreme ends of values. Right? Then in this case, if doing height and weight, it might be better just to identify the top view, maybe 4 meters, 3 meters. This could be data errors, right? But if you're doing things like, for example, sales or other things, depending on the context, right, you might want to use the 3 standard deviation approach. So at the end of the day, it really depends on your data sets and what you are trying to achieve.
Okay, let's move on. Lessons usually end at distribution is skewed, or there is no relationship. How does this relate to further analysis? What quantitative methods are there to confirm or disprove hypotheses created from visual EDA?
Skewed data. So you can. So how do you usually deal with this? Like if you have skewed data.
So when you have a distribution that is skewed, usually depends on what you're trying to do with a model. So most like linear type of models, they will kind of have this kind of assumption that your data is normally distributed. So if it's skewed, it's very heavy towards one end, you will want to do some sort of transformation to bring it back to normalcy. And also another thing about looking at the distribution is skewed problem is this concept of heteroscedasticity.
Oh, what's that?
So it is so basically all linear models or all I think most regression models have this assumption of heteroscedasticity, which is that the variance of your data is sort of constant. So even at small values or at high values, the variance will be constant. But in actual fact, that is usually not the case. So this is usually used as an explanation for sometimes when your model is underperforming, you'll say okay because the variance is very skewed. And so that is one way of making use of the data, having this outcome that distribution is skewed, so what, right? And then whether there is or no relation or isn't a relationship, that will help you to select features, for example. So if two features are perfectly correlated, then there is obviously a relationship, but then you might not want to include both features in your model because one will tell you about the other. So you're trying to you want to select features that might not have a linear relationship with each other to put into your model, such that your model is able to tap on the knowledge of each feature to create a final outcome.
Yeah, and that ties back to the PCA approach as well. Yeah, because PCA is trying to identify which are the variables that will contribute most to the models. Right? So if there are two variables that talk about the same thing, then PCA will let you know. For sure.
Cool. Okay, let's look at the next question. Does plotting affect missing value handling or vice versa?
Okay, I can answer this one. Okay. So when you do your plots, you should not modify your underlying data frame. So you shouldn't be like, oh, I have this figure and then I plot something from this figure, and after that, if I look at the data again, it has changed. So that should never be the case. Usually the plotting tool like Matplotlib will have some sort of way to deal with your missing values. Either you take it as 0 or you take it as like negative 9999. So it is usually up to you to handle them when you train your model. And you can do that by doing EDA. So in your EDA process, you will realize that like 5 values have a number of negative 9999. Then oh, that's probably a missing value. Or they'll show you like how many NaNs there are, and then you will have to deal with it appropriately. So this ties back to the importance of EDA on figuring out what data your model is, what pieces your data is lacking.
All right. How do you visualize and guess the correlations through time? If there are 7 data frames each for one day of the week for the same observed subjects with the same features, what sorts of visual EDA can be done and how? Must the 7 data frames be joined to create a single data frame with each feature having 7 columns?
I think there's a lot of different ways to answer this question. So one of the ways is usually for time series data, if you're looking at how something changes over time, you should look at the time series like a line chart, like a stock market, right? It's a line. If you are looking at how certain values changes on the day of each week, then it should be categorical. Then probably you can use like categorical plot, like a bar plot, right? Different, maybe like 7 days stacked together. This is the first week, this is the second week. So it really depends on what you want to find out, but I'm unable to provide further explanations without the context. So for the 7 data frames to join to a single one, I think that is optional because I think when you look if you use pandas, right, you load the data frames into memory. Technically, you can access the data frame through variables, like for example, like df1, then you put a bracket to access the columns. So or df2, you don't need to join them together. In fact, you might not want to, because doing so might give you these huge, gigantic data frames. So every time when you do some calculations or you run some analysis to it, or you just do a pair plot through Seaborn, it might give you this huge graph, right, which you want. So you should be selective on what you want to find out. If you just want Monday, then you could, for example, create a different data frame called data frame Monday. Then you put it together, so it's a data frame for Monday. If you run a data frame for, let's say, 3 weeks, then it should be data frame for 3 weeks. Then this might be doable if it helps in your data plotting and data analysis later on. So long story short is you should try to understand what is the objective you want to do. It's not just about combining data, right? It's about understanding why you want to combine data or understand why you want to keep data separate. Okay. So next, others.
Miscellaneous questions. When legend equals species in Ari's dataset in the video, it contains unique values from the species column. When legend equals to Latin America or Africa in the exercise, it is only a string. When does legend behave like each case? Is it the categorical color mapper in glyph that caused legend to change?
Okay. Okay. So this, I think for these questions, right? I think the fundamental question is if you have a text information or string information, let's say combo, right, or flower, should you keep it as a string or as an object, a data type, or should you convert it into a categorical format? So the answer is you should convert it to categorical, because by converting it to categorical, you will serve 2 purposes. The first purpose is that you are able to feed the information into your model. So usually when you convert a categorical data into, so you convert an object into a categorical, it becomes a 0 or 1, yes or no, male or female. When you have these values, then you can feed it into the machine learning to get further information from this. If you don't, then the machine learning models give you an error, say, hey, what's this? I don't understand. Right? Then the next reason why you want to convert the object to the categorical is because when you plot graph, like categorical plot, if it's a string, you can't use it as one dimension in the graph. You can only use it as a legend, like, which is pretty useless. Because legend usually is just manipulate what you want. So you should try to make use of the data as much as possible instead of just using it as a string. What do you think?
Yep. Definitely. Your model algorithm usually only understands numbers, not words. So it's important to convert names into categories. One thing to note of is that when you do that, your model might assume that just because 2 numbers are close to each other, that there's some sort of relationship, but that might not be true. So like if you have red, blue, yellow, green, and it turns into 1, 2, 3, 4, 5, it doesn't mean that 2 is nearer to 3 and 3 is nearer to 4, right? So you would have to do something like one hot encoding, for example, to separate out these variables, to remove this kind of like linear relationship.
Yeah, I think the only exception to what we said earlier is unless you're doing NLP, natural language processing. So if that's the case, then you want to keep the word as an object. Right? Then you do something called tokenization. So you tokenize the words, right, to process it. So if you're doing natural language processing, then you don't convert it, but you're doing one hot encoding. You need that. You need that text information. Otherwise, the machine can't understand. So at the end of the day, it really depends on whether are you doing NLP on, let's say, species, or are you actually modeling on continent. So that will drive different behavior and different things that you should do with your data set.
Makes sense. Cool, let's move on. Why must widget blocks be used here, or else it would generate an error?
For this, I think it's related to Bokeh. I think at the top level is that it's trying to force everything to have the same sizing mode, and it's required to have this complex layout to work. Yeah, I think that's very so this is a very technical question, but yeah, that's the short answer.
Okay, if I plot the astronaut in the exercise with plt.axis, it shows for the y-axis 0 is on top and for AT is at the bottom of the image. Why in the extend and aspect exercise, y takes is -1 to 1 reverse direction and goes from bottom to top of image. What's the correct ordering of rows for images?
Okay, so this is a question that is steeped in history because there are two fields that come in down here. So the first is in image processing. So we are dealing with things like photographs or in the past digital images. The convention people follow is that the origin is on the top left corner. So your x goes to your right, and then your y-axis starts from 0 and then it moves downwards. But when you're talking about arrays in in mathematics, they go the other way. They go from a bottom left origin. If you think of when you draw a graph, your 0 is always at the bottom left corner. So everything comes out from there. And so there's this conflict where sometimes if you're showing an image, they will use the image processing guidelines, and then they will show it like this. And then if you try and plot it as a colored 3D graph, they'll plot it from the other way. So these methods of using reversing your y takes is just to help to correct for that difference in the programming background. And at the end of the day, you have to go and look at the underlying plotting function and see what kind of assumptions they're making, or just figure out what works and then you can just stick with that.
Yeah, but again, so on a high level basis, right? Let's say 1 is -1 to 1, 1 is 0 to 40. Would that impact anything on the modeling side?
It shouldn't really impact much. Yeah, it's just mostly for plotting convenience. Yeah.
So if it doesn't really impact you that much, so it doesn't really matters if it's one axis or another, and there's really no need to worry about you need to change the axis or not. If at the end of the day, if you're doing that new network processing for image, everything will be converted to the vectors of like one string of numbers. So the axis won't really matters in most cases.
As long as as long as everything you do goes through the same process, they'll be processed the same way. So the results should be this.
Okay, cool. Let's see. Data frames are joined to add information about entities. Are there any examples of plots being joined, and what can they reveal? For example, join plot looks like a join of histogram and scatter plot.
Yep. So this is a great question. When you compare two variables, this kind of join plots are useful in telling you two things: the correlation and the frequency. So it's basically, essentially it's a way of condensing the data in a way that looks beautiful. So people do other things that there's somewhat this kind of condensation feature, like like violin plots, for example. So these are a good way of knowing at a glance what's going on. Another way it helps is that you will also be able to intuit what's the data density along the correlation. So you know how reliable it is, or how many points that fall within this correlation line. Is it like in the center of my distribution, or is it at the far end? So you'll be more aware of outliers, and that can help you to explain your data to other people.
Okay. All right, let's see. Okay, so this is a question for Tempo. Someone from the finance sector, what were the biggest challenges and first steps you took towards your data science/AI journey, and how did you overcome them?
Okay, so prior to joining AAP, right, I was working in P&G as a procurement manager. So my bachelor's was in finance, international trading. So I have zero background knowledge in Python and AI and machine learning. So the biggest step the biggest challenges is always getting the first step, right? Like how do you install Jupyter? How do you install Anaconda? Then what is the Python thing? And so you're trying to get familiar with the programs and how the workflow is done. I think that's the first hurdle. Of course, then the subsequent hurdle is learning the programming language, right? So even today, when I don't know anything, I'll go to my good friend here again to ask him, how to do this, how to do that. Because right now, as of today, we are all still learning from each other, right? And data science itself is so huge, right? There's so many things to learn, like math, programming, the domain knowledge, the cloud server, and everything else in between, right? So it's impossible to almost know everything at such a short notice. So I think if you are really interested in data science, you should choose one or two areas and really go deep into it to be proficient in the areas. And of course, learning online courses like Datacamp, Udacity, all this will help a lot because I think they have created content. They can give you actual real feedback on what is working, what is not working. Although sometimes you will tear your hair out and say, why this is not working? It's exactly the same code. Right? Actually, then realize there's like you miss out one comma, one full stop, or something like that. Yeah, so this is something that you have to be familiar with.
Cool. Thanks for sharing.
Thanks for sharing.
Okay, let's see. Do we have any?
No, that's the last question.
Okay, so now Turbo is going to present a notebook that he's put together for you.
Yeah, so we'll go back to our favorite data set, like Titanic. Right? So Titanic is our favorite data set. Okay, so before I start, I'd like to introduce this keyword called feature engineering. So what exactly is feature engineering? Like, I'm not an engineer, why don't you do feature engineering? so feature engineering itself, it means that you're trying to get intimate with the data. Let the data tell you more things. For example, let's say you have names, right? So names is like Mr. So-and-so, Mr. So-and-so. Or some could be Dr. So-and-so, right? So instead of just treating them all the same, you could do some feature engineering to separate out the certifications of the individuals and the names. So then you can use the certifications as features. By features, I mean data that can be used in the model to predict something or to train the model to let it improve. For instance, let's say if I'm doing a modeling on prediction of individual income, right? So that potentially certifications of the individual might mean a lot of things. Right? As you know, professor, doctors, they earn a lot. So by using this information, right, it could be a potential indicator of a person's income versus people like Mr. and so forth, who might not have a high education. So that might impact the model. Right? So this analyze the concept of feature engineering. So the reason why I'm doing this today is because I realized that Datacamp, they don't really dive deep into the feature engineering part. Right? It's very prescriptive, right? They ask you to code line by line, instructions by instructions. So that's why I'm trying to go through this Titanic notebook in details with you to let you know how is the workflow being done usually and how feature engineering is done, right? So so first part, you import a notebook. So this is the normal things I do. Then you read in the file, Titanic file, right? So this is a basic I will go through. We have been through this 2 or 3 times already. So then you read in the data. So of course, this is exactly what Leakage, I think 2 weeks before presented, right? You have to head, look at the data, what's going on, and look at the data set. Okay. So if you look at here, right? Okay, so this is where what we presented earlier on will come into play. See, sex. Sex means like male or female, right? But it's object. You know this is wrong, right? So you see here, I written down. So survive, P-class, sex, embark. Cabin should be categorical data, right? And you look at here, embark is 8 and 9, right? But the rest is 8 and 1. So there's 2 missing values, right? For cabin, look at cabins here. Yeah, so it's C85, C123. So C seems to be the class of the cabins, right? So potentially you want to split that out to get the cabin category, because you know, if you've been to a cruise, right, the A will stay at the top, the Z will stay at the bottom, right? So when Titanic hit the iceberg, right, at first hit the bottom, right? So if you're staying at the bottom, of course, you have a lower chance of surviving, right? Like Jack getting stuck behind the gate, right? The scene. So then that could impact whether someone survive or not, right? So this is the background information that you should have by reading this info column. So next step. Next step, of course, say you correct data type. So basically, this entire session here, what I'm doing is that I'm correcting data type, right? So basically, I define a function to change the category. So basically, here I change everything here, the survive, P-class, cabin, and bug to become categorical, right? And because survive and P-class, right, you need to encode them. Otherwise, you can't fit them in the model, like what we mentioned earlier, right? If you're just a string or ABC, right, it's hard to fit in the model. You need to turn it into numerical numbers. That's why there's cat code here. So basically, this converts the values to numerical values, right? So if you run it, then see, now cabin and bug data is become category. Yeah, so now you know this is working. And you see, like the sex, male, female, right? So it become encoded. Yeah, right? And if you see his UNT8, right? Basically, it just means that it's encoded, right? It becomes 0 or 1. All right? Okay. So, what I'm doing here is that I'm basically dropping out all the columns and all the rows that have missing values, or those columns which are not encoded yet. And the reason why is because I need to run this through a machine learning model called random forest to predict whether someone will survive or not, right? So if I don't do this step here to pre-process the data, the model won't be able to understand. They will say, hey, there's one missing value, and hey, this is a word, not a value, I cannot take it. So this entire section here is just to process the data to make sure that it can be fed into the machine, right? Then this is the initial model. So usually in a data science workflow, you just run this initial model. This is under the supervised learning module in Dataframes. So you run this, right? See? So just run this and you get accuracy score around 80% plus. So you'd be surprised that just a very simple model by itself, just call it and run it, right? Without further feature engineering, right? You get around 82% accuracy, which is very impressive, right? Can you imagine, like, by giving your gender, your cabin class, your age, or things like that, the machine can know that whether you'll survive or not. And 82% accuracy, that's pretty impressive, right? So if your stakeholders or your boss do anything on machine learning, right, you're done. You submit your homework, right? 82%, that's very good. But of course, you don't do that, right? Because as a data scientist, you try to dive deeper into the model to get better accuracy. So this is where EDA, exploring your data, and feature engineering comes to play, right? So this is where I'll explain more now. Okay, so of course EDA, we made a heat map. So I did a function, I called it heat map, right? So look at here. So basically, this tells you the correlations of the variables, right? Like how closely they are correlated with each other. And this could potentially give you the variables that you should start looking at first. Like for example, like gender, like male, female, 54% correlations with survive. That's interesting. Fair. So potentially these three could be interesting to look at, and the P class as well. Yeah, so with this, you can sort of identify which are areas that you want to deep dive into, right? So you see here, like sex and fair have the highest correlations, right? So then this way you go deep dive into each variables, right? So first look at the passenger ID, right? So passenger ID is here. So what I did was I printed out the first 5 rows of passenger IDs, right? Because the initial hypothesis is that the passenger ID could signify the relationship between passengers, because they bought tickets close friends go on holiday, and as usual, right, if your BFF with you go for holiday, you got problem, what do? They take care of you. Yeah? So potentially more people come together in a group, then maybe they have some relationship, then they can survive, right? So what I did was I split the family name and first name. So here, surname. Look at here. So this is the feature engineering, right? So I split out the surname from the whole name and see, okay, they all have different surname and their passenger ID are all different, but they're all consecutive 1 to 5. So potentially the passenger ID is just an index, so it doesn't mean anything. So what I did was I just made them into an index instead of being a data set. So when this happens, right, basically what I tell the model is that just use this column as an index of the data. It won't fit in the model to impact anything. So this is the first step. So next, title. So title passenger, look at your title here. Name, right, there's Mr., Mrs., Miss, Mrs., Mr. something. So out of curiosity, right, I printed out the unique values of the title. So from here you can see, so there's Mr., Mrs., Miss, Master, Don, Reverend, Doctor, Madam, Miss, Major, Junkie. Yeah, so all these are different title of the passengers. So of course you don't know anything about this, right? So I went to Wikipedia, take a look. So I come this table here. So basically, Colonel, Don, Junkie, Lady, Major, Master, they are all honorific title, meaning that they are bestowed upon you by the emperor or whoever at that period of time, right? So imagine you're on a cruise, you are a colonel, right? So potentially you have wider influence and more money potentially to influence the staff to give you priority boarding. Like if you're boarding on a plane, like priority boarding. So then the rest are Mr. Mrs. That's generic. Then you see here, like mainly MME, they are like Miss and Mrs. equivalent in French. So these are French, right? And why French? Because they are just happen to be there, right? The pot or the 3 pots. Yeah. So then you don't want to deal with so many different variables. So you convert everything to this. So what I did was I convert everything to Mr., Mrs., Miss, male honorific, male others, female honorific, right? So so this is another part of feature engineering, right? So by looking at the salutations of the passenger, you identify their social class, you group them together, those for honorific, then you run through analysis, right? So you plot the categorical plot, right? So this is where it ties back to the EDA and visualization, right? If you don't convert them categorical, you run this inside Seaborn sns.pairplot, you'll throw an error, say, hey, what are you doing? I don't understand what you're trying to do. So by converting them at the start into categorical data, I can plot this graph out. So you can look at this chart, very interesting, right? On the left is 0 means they're dead, 1 means they survive, right? So look at this, male honorific, right? So in general, all the males, they are poor soul, right? Most of them perished, right? But look at this, right? Male honorific, okay, some of them died, but a majority of them survived. See, so this is interesting, right? See, like, so this shows that if you are doctor, colonel, or those special people, right, you have higher chance of survival. Look at this, male others, all of them are dead, right? So male others here, like maybe 1 survived, there's a small harm here. Yeah, so this shows you very interesting data insights into Titanic, right? So okay, if you're male, probably you are dead. But if you have a PhD, like my doctor, then you'll survive, right? So things like that, so interesting. And of course, if you're female, like you are Mrs., Miss, right? Probably you'll survive. See, doesn't matter, right? And at that point of time, the society sadly, the female honorific, the sample size is not a lot. That's why you don't see anything here. Probably at the time, it's harder for female to get something that's honorific, right? Because at the time, society is different, right? So then, of course, then you convert then the categorical data, then do a heat map here. Yeah, so this is a new heat map that we plotted, right? So with the new information, right? Now you see here. Initially, it's just here, right? Now you see here. So there is a honorific Okay, let's see here. Survive. Okay, if you are a Mr., you probably date 55% correlations. But let's say if you are male on the fake, it's 0.009. It's still small, but at least it's a positive correlation to survival. You can survive, so that's good. So this interesting insight you get from it, right? And of course, then the next variable is the name, right? So look at names. So let's run names, and you see here. So what I did was I did a unique value of the surname. So this function is called right again 2 weeks ago. So you can see the names. There are 67 unique family names, right? So think of it like if you want to fit this in the machine, you need to convert the numerical numbers, do one hot encoding. But we do this, you have 667 columns of data with a lot of zeros in between, right? If you understand one hot encoding, right? So this doesn't make sense because if you fit this machine, right, there's so many columns, right? So it doesn't make sense at all. So what I did was end up I decided to drop the name and surname from dataset. So I don't think the names itself is important features. So end up, look at my data set. It's just male, female, and a title without the name of the passenger. So this is feature engineering as well. So this feature engineering at work, like engineering the features, right? So next, embark. So if you read Wikipedia, it says Titanic depart from Southampton, England, then Tableau, France. That's why got French passengers. Then the Queenstown, Ireland, and wrote to New York City, right? So this is the part of call. So then the initial hypothesis is if you bought the boat early, you might know the start time, you might know the layout of the ship. So when the ship crash, right, you know how to get out the shortest shortcut way, or you know the chef, whoever, the boatman, so they might give you priority boarding, right? So that's when you can do this. Right? So then you can see whether the part of call will have any influence on this survival rate. Yeah. So I think this is the last part that I will go through. I have to cut short because I think we are running out of time. If you have any further questions, feel free to drop us an email. Then we'll reply to you as soon as possible.
Yes. And don't worry, as usual, the whole AMA will be recorded, and all of these answers will be sent to you in the newsletter.
Yeah. Have a good weekend and a Merry Christmas. Hopefully you'll get your deserved presents.
And I'll see you back in the new year.
Yeah. See you.
Right.
Thank you.
Bye-bye.
Merry Christmas.